When we're talking about odds, what we're really talking about is the number of ways an event can happen as directly compared to the number of ways it doesn't. That is, we're directly comparing an event to its complementary event, where this is a notation that's used in context often of gambling to talk about how likely something is directly in terms of, well, two options instead of looking at a probability, which is maybe a bit more abstract than what people like to see. So we have odds in favor as well as odds against, where the odds in favor are computed by taking the probability of the event and dividing by its complement's probability, whereas against is the complement over the original. And we'll see that when we do this, some things are going to end up simplifying, and you'll end up with one number over another, which we write with a colon, as we'll see here with a couple of quick examples. First, we're going to find the odds in favor of and against rolling a 3 on a standard die, where what we should do here is understand that the probability of rolling a 3 is going to be 1 out of 6, as we've seen before, while the probability of rolling a not 3 is everything else, 5 out of 6. So if we want to get our odds in favor, this would end up being, well, 1 out of 6 divided by 5 out of 6. As I said, the 6's cancel. We get 1 out of 5, or 1 to 5. That's where that notation of 1 to 5 comes from, is the division of the two probabilities. Meanwhile, if we want to talk about the odds against, and yes, I know I didn't leave enough space there. I made it look like in favor is one word. Don't worry about that. We do the same thing there, except we flip the division. So when you flip those divisions over, you'd have 5 over 6 over 1 over 6, which would leave you with 5 over 1, or if you prefer, 5 to 1 against, because this says there are 5 ways for it to not happen compared to the one way that it does. You can also think of it pretty directly in that way in terms of the values there on the top, as it were. It's cleanest when you have something nice like this, but you can deal with things that are maybe a bit more complicated as you deal with other real-world scenarios. So let's try going into the real world for another example and one more quick concept to develop along with it. Suppose the odds in favor of a particular horse winning a race,
they're off,
are 2 to 5.
Little Miss Macho had a bit of an awkward start. My wife knows everything broke well. Lady Butata is up and on the pace. Rojo's Tune is out third. The wife doesn't know, fourth to the outside, and Eleni's Hope is fifth.
What is the probability this horse will win the race? In this case, we are given the odds in favor are 2 to 5. And if we want to be able to find the associated probability from that, what we need to do is take the value here, PE, is going to be equal to the first one, the probability associated with A, divided by A plus B, where this comes from a little bit of cleverness with fractions and understanding what we have here, that A is the number of ways that what we want can happen. A plus B is the total number because it's either the things we want or the things we don't. So here, the probability we would get would end up being 2 over 2 plus 5, or 2 out of 7 is their probability of the given horse winning the race.
My wife knows everything. The wife doesn't know. They're 1, 2. Of course they are. My wife knows everything in front. To the outside, the wife doesn't know. My wife knows everything. The wife doesn't know. My wife knows everything. More than the wife doesn't know.
So that's all we've got here for section 11.6. Jesus, hard to keep track of just how fast we're moving here. Next, we're going to finish off chapter 11 with some look at multiplication, and then start moving into chapter 12 to look at statistics. See y'all in there.